If you go back and you watch the very introductory lesson to the course from way back months ago, you'll see that one of the topics I mentioned we would most likely get a chance to cover would be patterns, software patterns that relate to concurrent programming. And this will include both patterns related to multi-threading as well as patterns related to synchronization. And so we got to a point now where we've covered the bulk of the mechanisms. And so what I think we'll do now is spend a little time talking about some of the software patterns that appear within the Java frameworks that we've talked about for concurrency, as well as some of the frameworks that occur within Android that layer upon and build on those particular Java frameworks. So we're going to take a look at a few different features. Some of these features come out of Android. Some of these features come out of the Java executive framework and other parts of Java util concurrency. And we'll see how these mechanisms are going to be guided by various patterns from the concurrent patterns literature. And in particular, we'll talk about some patterns from the Pattern-Oriented Software Architecture book series, the POSA series that I co-authored many years ago, as well as some of the patterns from the Gang of Four book. And particularly, we'll look at things like thread-specific storage, command processor and active object, half sync, half async, monitor object, and maybe we'll look at pipes and filters, although that really requires more knowledge of Java streams. So we may not cover that in detail here because that's really a topic more for my next course that'll occur next fall. And we'll talk about the different patterns that show up here. And it's really fun to understand these patterns. So Android and also Java have these concurrency frameworks that apply a whole bunch of POSA and Gang of Four patterns to overcome various design constraints that they have to be restricted by to do their thing, especially in Android, as well as to ensure various quality attributes, typically things like reusability and understandability or scalability or flexibility and so on and so forth. There's a number of different frameworks that Android provides in order to be able to give you concurrency. And these frameworks, in a nutshell, are the handler or handlers, runnables, and handlers, messages, and runnables framework, or the hammer framework. That's why I have a little icon here with a hammer. And then the other one is something called an async task. And these are two very interesting frameworks. The hammer framework has been around for quite a long time, and it still is used in Android. The async task framework has gone through a number of iterations over the years, and in very, very recent versions of Android has kind of been deprecated in favor of other things. But it's still an interesting framework to be aware of, and it implements some very, very cool patterns. But we won't spend a lot of time on the async task framework anymore because it's no longer encouraged for modern Android usage for a variety of reasons. This is kind of a picture that illustrates these different frameworks, and I'll be using this picture to kind of talk about how they work. And of course, the main goal here is to talk about how the underlying framework implementations use these various patterns in order to guide their behaviors. And we talk about these things in the context of Android concurrency in the form of so-called idioms. And an idiom is basically a pattern that's restricted to a particular context, something like a particular platform or a particular language or a particular operating system, and so on and so forth. So as you can see here, if you take a look at the link down below, programming idiom, it talks about how an idiom is kind of a limited pattern. It's still a pattern, but it's a pattern that's really specific to a particular context. And we'll talk about some of those things here. So these examples would largely relate to Android, although you see that some of the patterns are also broader than that. Here's a very simple example. Android provides this interesting message passing model that uses a method called send to target, where messages can be passed between threads using this Android mechanism in terms of the Android concurrency frameworks. You won't find that particular method used in that particular way more broadly in other Java applications. It's very important to be aware of patterns and idioms when you start to program concurrency in Android. And that's because they have certain design constraints that they have to be able to fulfill. And a lot of these things come down to the fact that a mobile device framework for user interfaces has to have certain limitations on how it works. And there's also other constraints, like they need to be able to change the orientation by rotating the phone and so on and so forth. There's also other patterns that are very useful to structure Android applications. One that was popular a number of years ago was called the Model View Presenter, or MVP pattern. And you can read more about that pattern down below. A lot of my earlier implementations of Android were heavily structured around Model View Presenter. Over time, other patterns and idioms have crept into use in Android, especially if you're using Android apps to access persistent data stores. So just be aware that there's a number of various ways to structure Android applications. Another example is you need to copy messages that are passed as parameters to some of the hook methods in the Hammer framework before storing it, because they do some kind of clever reference counting that means that the messages will go away once the method comes back. So if you want to keep a copy of it, you have to copy it yourself.